Earth's crust may be peeling away deep beneath California, like a moth in a cocoon. The metamorphosis of Earth's crust from molten goop to solid land is hidden from view, leaving scientists to guess at how the eons-long process unfolds. Using nearly 4 decades of seismic data from stations encompassing the northern, central, and southern Sierra Nevada along California's eastern border, geologists have uncovered signs of critical separation between the cool continental crust and the mantle below. The findings, made by researchers Vera Schottel-Pelcom from University of Colorado Boulder and Deborah Kilb from University of California, San Diego, help resolve the perplexing mystery on how our planet generates the lighter portions of its crust from the dense mix of minerals churning beneath. And thanks to their relatively higher proportions of minerals that include silicates, aluminum, and potassium, the chunks of rock we live upon typically rise a touch higher than the submerged rocks, the chunks of oceanic crust, which by comparison tends to be richer in heavier elements like iron and magnesium. Now, how these materials form and why they're so different is an ongoing question that researchers are slowly piecing together. The heavier elements in oceanic crust are parts of the basaltic recipe found in the upper mantle, implying the makeup of the continental crust could be the result of denser components separating out of the mix. One means by which this could happen involves the dense basalt melting a while wet and under great pressure, allowing its minerals to separate into relatively distinct sheets, and being so heavy, the lower layer might then peel free to slowly sink into the circulating currents of molten rock, making up the rest of the mantle. It's an appealing hypothesis in need of solid evidence, so Schultz, Pelcom, and Kilb went hunting for signs in a location some suspected was steadily being stripped of its heavy igneous roots. The Sierra Nevada, and this is a beautiful picture of it, is in the seismically active region of the western United States, allowing researchers to use the speed and reflection of waves rippling from constant tiny tremors to map the depths beneath the mountain range. Signals from these ripples, along with examples of mineral fragments of one sort enveloped within rocks of another, were already convincing some geologists that the region had experienced delamination, that's separation of layers, in the past. Unfortunately, the same clues could be interpreted as remnants of long buried slab of crust, demanding additional reading to clarify the region's seismic anomalies. Comparisons between seismic datasets representing different depths between the Sierra Nevada confirmed a vast shear zone under the southern and central areas at depths close to the mantle boundary. This zone becomes increasingly distinct towards the mountain ranges south. The sense of shear is consistent with west to the southwestward removal of lithosphere, the researchers write in their paper, confirming theories the heavy base of California's crust has been sinking over millions of years, tearing itself free over a span of hundreds of kilometers in a process that could be mirrored in similar chunks of continents all over the globe. And what we see above the surface, from the rise and fall of mountains to the sinking of vast basins into the emergence of the entire continent, is mirrored by a complex shearing, dripping, melting, and wearing out of sight tens or even hundreds of kilometers below the surface. And if we listen in just the right way, we can hear the skin of our planet softly stir as it ever so slowly changes. And this is from Geophysical Research Letters on Science Alert by Mike McCrae. Please leave your comments and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.